Hello everybody, this is Mr. Bowman. So right now, today we're going to be looking at the ALEKS topic, graphing a system of two linear inequalities, and this is the advanced version, so we're going to have a little more work to do before we start graphing. So because of space issues, I'm actually going to work over here, so I'm going to go ahead and color code these. So I'm going to make my first one in that blue and my second one in red, so you can see what we're doing and keep them all straight here. So starting over here, I have 6x plus 5y is less than or equal to negative 5. So my goal at this point is I would like to get this in more of my slope-intercept form. I want to get that y equals, not really equals, mx plus b form so that's easier to graph. So I want to solve for y. So I'm going to subtract the 6x from both sides. And then these are not like terms, so I can't combine them together and say negative 11. But what I can do is go ahead and change the order a little bit so that it's mx, and then the b comes after. So I'm going to put the term with the x first. Okay. We have a lot of negative signs floating around, so make sure you're careful with that. All right, one last step to get the y by itself is I have to divide by 5. So I'm going to divide everything by 5. And it's a positive 5, so I don't have to reverse my symbol, which is negative 6 over 5x, and 5 over 5 is 1. So I'm going to go ahead and graph this, and then I'm going to deal with the other one, since I like to go all the way to the end with one equation before I deal with the second. All right, so I'm going to start at negative 1, that's my y-intercept, and I have a slope of negative 6/5. So negative 6 is negative, 5 is positive, so down 6, right 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 3, 4, 5, 6. 1, 2, 3, 4. Yeah, 5. Okay. And then I like to go the other way and get as many points as I can. So I'm also going to do the opposite direction. So I went down and right. So I'm going to go up and left. So up 6. 1, 2, 3, 4, 5, 6. Left 1, 2, 3, 4, 5. Okay. And then now that I have my general shape, I have my two inequality things to focus on. Is it solid or dashed, and where do I shade? So looking at this one, it's less than or equal to, so that's going to be a solid line through my points. And then where am I going to shade? So for this one, remember we want to usually have a test point. So I'll do that over here. Since this doesn't go through my origin at 0, 0, that's on the upper, if you will, side of my line, as opposed to the lower side here. I'm going to use that because it's the easiest thing to plug in. So I have 0 for my y, 0 for my x, which lands me at 0 is less than or equal to negative 1. That is false. So that means that the side with 0, 0 is false and not the side I want to shade. So I would like to shade down here. Okay. All right, now for my second one, I have negative 3x plus 7y is greater than 21. So same idea, I want to still get the y by itself. So add 3x, and once again, these are not like terms, and I want the x to be first, so 3x plus 21. Divide everything by 7 to cancel out my coefficient there. So I end up with 3/7 x plus 3, 21 over 7. And so I can go ahead and graph this guy now. So I start at positive 3, 1, 2, 3, and have a slope of positive 3 over positive 7. So up 3, 1, 2, 3, over 7 would be right there. And likewise, like I did here to get my other point, I will do the opposite directions. So down 3, and then left 7. All right, so now I have just a normal greater than, which means it's going to be a dotted or dashed line, depending on how you draw yours. And then for my shading, it still doesn't go through the origin. It's on the bottom half of my red line. So I'm going to see if that bottom half number is included or not, just by seeing if it's a solution. If it is, then it would be shaded there. If it's not, it would shade the other side. So 0. 0 for x. So I end up with 0 is greater than 3. That is also false, so that 0, 0 is not a solution for red either. So I'm going to shade instead of the lower side, I'm going to shade the upper side. All right, so now comes the important part. How do I interpret my answer to figure out what the actual answer is? In order for something to be a solution, it needs to be included in the solutions for both of them. So we're looking for the shaded region for blue and the shaded region for red. So this is a little trickier in terms of what if you actually land on the line. So I'm not going to get into that too much right now, but just a quick version. Since this is a solid line, those are solutions. So if it's on the solid line and for the blue and shaded for red, these would be solutions. But these dashed line ones are not solutions. So like this point right here, even though it's shaded for blue, is not included in red because it's a dashed line. So you have to be very careful when you're talking about the lines themselves. But in terms of shading, I'm going to look for it's just blue down here, so that doesn't count. There's nothing over here, so I definitely don't want that. There's just red up in this top section, so I don't want that. So I'm looking over here where both red and blue are shaded for my final answer.